All right, in section 5, we're going to start looking at the beginnings of trigonometry, but before we get too much into that, we're going to look at the definition of an angle and some ways that we can measure angles in the plane. So an angle in general is when you have two rays that are connected by some common endpoint, and so this is an angle. The space in between this is what we call the measure of an angle. And we'll have a couple different ways to measure angles. But typically, we've measured angles in degrees. And degree is just 1/360th of a circle. So if we have a full circle and we divide it into 360 little pieces, then that angle that's formed is 1 degree. Now, another way we like to measure angles is if we try to measure smaller parts of angles. So if we have 1 degree and 2 degrees, there are infinitely many degree measures in between those two, all the decimals and things like that in between them. So we like to have a little more specific way to measure those, and we call that minutes and seconds. So a minute is actually if you take 1 degree and you split it into 60 parts. So 1 minute, which is defined as a little dash, little apostrophe, is 1/60th of a degree. So if I take 1 degree and break it into 60 parts, so really, really, really tiny angle, we call that a minute. And then same thing for a second. If we take one of those minutes and break them into 60 parts, we get a second. And a second is 1/3600th of a degree. So really, really, really small. So we call this DMS form. So if I take any angle in DMS form, so if we have this degree measure, let's say we have 3 degrees, 42 minutes, and 36 seconds. What I know about this angle is it's some angle between 4 and 3. So it's slightly bigger than 3, smaller than 4. So all the minutes and seconds all are adding something less than a degree. But when you're dealing with large scales, things in astronomy and different sciences, a little difference in degree can actually be a big difference in actual distance. So if you look at this angle, we have a couple where we have DMS form. If we have 42 degrees, 30 minutes, and 9 seconds, what would that be in decimal form? Well, what I know for sure is this would be 42 point something degrees. And the way we do it is we can actually convert the minutes and seconds into degrees. So we have 30 minutes, but every minute is worth 1/60th of a degree. And we have 9 seconds, but each second is 1/3600th of a degree. So we can simply multiply these together. So 30 times 1/60th is 0.5. 9 times 1/3600 is 0.0025. So our degree measure, if I just add 42 and 0.5 and 0.05 together, is going to be 0.5025 degrees. So when you see 42 degrees, 30 minutes, and 9 seconds, that means 42.5025 degrees. Same thing for this one, 118 degrees, 46 minutes, and 19 seconds. I know this is going to be 118 point something degrees. So I'll take the 46 times 1/60th, and I'll take the 19 times 1/3600th. And that will give me the minutes and seconds in degree form. So 46 times 1/60th is going to be it's 0.76 repeating. So let's just go like 3 6s and then a 7. And then 19/3600 is going to be 0.00527 repeating, so we'll just say 8. And then we'll just add these two together. So 0.7767 plus 0.00528 that is going to give me 0.77195 degrees. So again, 118 with the minutes and seconds, just slightly bigger than 118, bigger than 118, less than 119. Now, we really do like the decimal form of degrees. It really makes it easy. We kind of all understand what a decimal is. But if you want, you actually can turn angles that are in decimals into DMS form. It's kind of a more bizarre process. So we'll look at one example of how this would work. So if I want to turn this to DMS form, so I'll have some number of degrees, some number of minutes, and some number of seconds. Well, I know it's 31 degrees, so there's 31. So this 0.425 is all part of the minutes and seconds. So how I will do this is I will take 0.4125 and I'll multiply it by 60. This will tell me how many minutes I have. 4125 times 60 is going to be 24.75 minutes. So I have 24 minutes. I put that in the wrong spot. 24 minutes in front of that symbol. So now what we have to do is we have to take the leftover, the 0.75. Now that's going to be our seconds because that's a portion of a minute. So if I take 0.75 times another 60, that's going to give me 45. So that's going to be how many seconds I have. So you just take the decimal and you multiply by 60, and then you take the remaining decimal and you multiply by 60 again, and you can turn 31.4125 degrees into 31 degrees, 24 minutes, and 45 seconds. So one way we're going to look at angles a lot, we're not going to look at angles typically as a stagnant thing on the coordinate plane. We're actually going to kind of think of them as dynamic things. So what we're going to kind of think of angles as, we're still going to have two rays, but instead of having just two rays sitting there, I'm going to think of one ray starting out, and then I'm going to think of both rays together and then one moving. Maybe one moves in this direction. So we'll actually have a direction where these rays move. So this angle that you see there would be very different from this angle here. Even though the rays look in very similar positions, the way it gets there is different. So the way we do this is we use what's called standard position angles. So we will give names to the two sides of our angles. So the initial side is the starting ray for the angle. So you kind of think of the two rays together. And then the terminal side is going to be the ending ray of the angle. Now, we just kind of drew two angles just kind of out in the middle of nowhere, which is fine. But in trig, we like to standardize everything. We like to have everything basically start and finish at the same place. So to do that, we come up with what's called standard position angles. Now, a standard position angle is going to be an angle graphed on the XY plane with an initial side along the positive x-axis. So we're going to start our angle on the positive x-axis, and then we're going to kind of go from there. So if I have my XY plane here, I'm going to start my angle looking this direction, and then I'm going to have it move somewhere in the plane. Maybe I have it move all the way over here. So we have our little direction, our little arc that shows where the angle is going and where it finishes. So we have our initial side on the positive x-axis, and our terminal side in this case is in quadrant 3. So by definition, when you start doing things in standard position, you can actually have positive or negative angles. So a positive angle is just one that's going to rotate counterclockwise. So if it rotates counterclockwise, we say it's positive. If it rotates clockwise, we say it is a negative angle. So in this case, this would be a positive angle because it rotates clockwise, and this would be a negative angle because it rotates, or counterclockwise for positive and clockwise for negative. So if we want to graph a couple angles, for example, we have 172 degrees and negative 300 degrees. So, and then it says name what quadrant the angle lies in. So we always start to the positive x-axis, and it says we're going to rotate 172 degrees. Well, I know going all the way flat would be 180, so 172 would be somewhere like that. That's 172. And it's positive because it's going counterclockwise. Now when it says what quadrant does the angle lie in, we're just figuring out what quadrant does the terminal side lie in. In this case, that would be quadrant 2. Let's look at negative 300. Still start at the same spot, but we're going to rotate clockwise this time. So there's 90. There's 180. Got to keep going. There's 270. So I have about 30 more degrees to go. So this is what negative 300 would look like. So now we have a pretty good idea of what degree measure looks like, how we measure angles in degrees, but there actually is a different way we can measure angles, and we call that radian measure. Now what radian measure is going to do is it's going to essentially measure angles, but instead of using degrees, which is a portion of a circle, it's actually going to just use segment lengths. So how we do measure in radians is we actually are trying to figure out if we take on some circle that this angle is pertained in, and we take some radius r, well, this angle from this radius r will make some arc length here at the edge. And so radian measure, which we typically will say theta or some variable, theta is a pretty famous variable for angles. Theta in radians is just this arc length divided by the radius length. And this radius can be any size. If I put my radius way out here to make it here, then my arc length would be bigger. But when I divide it, I get the same number. So this example here I have the arc length. This arc length is the exact same length as the radius. So this is actually a radian of 1 because the arc length is r and the radius is r, and r divided by r is 1. So this is an example of 1 radian in quadrant 1, 50 some odd degrees. And we will have a way to convert from radians to degrees. But in this case, 1 radian looks something like that. So if we look at a different angle, here I have some radius I marked off as 4. And its arc length is 8.7. So if I wanted to measure theta in radians, which if you've noticed is unitless, there's actually, there's no degree, there's no real symbol. You can write radian, but you really don't have to. Because it's a ratio of 2 lengths, this is going to be 8.7 divided by 4, which is 2.175. That is the radian measure. If you want to put RAD for radians, you can. But in general, we could say that angle measures 2.175. And if you don't say degrees, it is assumed that you are talking radian measure. So it is very, very common for people to say, I need an angle of measure 1, and we just assume that is radians. Or a radian measure of pi. A lot of the radian measures will have pi involved in it, as you will see when we look at the conversion formula. Okay, so like I mentioned, we can actually convert from radians to degrees and degrees to radians, and all we have to do is multiply by these special factors. So if I want to go from degrees to radians, I'll multiply by pi over 180, and to convert from radians to degrees, I'll multiply by 180 over pi. So when you have things in radians, very, very common for them to have the unit of pi in them. So these first 3, I have very standard degrees. Everyone would pretty much know what these degrees are, but I want to turn them to radians. And then for the second set, I will take the radians and I will turn them to degrees. So if I have 200, remember when I'm going from degrees to radians, I'm going to multiply by pi over 180 degrees. So I'll take 200 degrees times pi over 180. So the degrees will cancel and give me that unitless measure. Now the way we will typically write this is we'll keep pi in my answer, and then I'll just take what is 200 divided by 180, and I'll put it in front of pi. Now obviously that reduces. I can cancel a 0, and 20 over 18 reduces to 10/9. So my radian measure is actually 10 pi over 9. So I always want to have it something in pi if I can for my radian measure. Same thing for negative 120. Negative 120 I'll multiply by pi over 180 degrees. The degrees will cancel. So I'm going to end up with negative 120 over 180 pi. Zeros will cancel. 12 over 18 both divide by 6, so that's negative 2 pi over 3. Same thing for the last one. We have negative 17. So negative 17 I'll multiply by pi over 180. Now in this case, you really can't simplify 17 and 180, so my answer is simply going to be negative 17 pi over 180. And that's fine. We like to reduce the fraction if we can, but there are cases like this one where you can't. Now, taking something that's in degree and turning it to radian is probably something that we won't do as much in this class. But if you have something in radians and you want to turn it to degrees, we'll do that a lot more. Because everyone is pretty comfortable with degrees, less comfortable with radians. So if I want to convert the following into degrees, to graph it or do whatever I want, remember when I'm going from radians to degrees, I'm going to multiply by 180 over pi. And the nice thing about this is when you do this, a lot of times the pi's will cancel out. So we have pi over 4 times 180 over pi. So my pi's will simply cancel out. So I'll be left with 180 divided by 4, which is 45 degrees. So 45 degrees, which is a pretty famous angle, it's half of a 90-degree angle, is exactly pi over 4 radians. Those mean the exact same thing, just measured in different ways. So the next one, same idea. It's 2 pi over 7 times 180 degrees over pi. So these pi's will cancel. So I'll get 360 degrees divided by 7. So 360 divided by 7 is going to give me, it is a decimal, it doesn't turn out nice, but it's 51.43. We'll round to the nearest hundred. Finally, we have 4 radians. Now in this case, there's no pi, so it's just 4 times 180 over pi. There's no pi to cancel, which is okay. You don't have to have a pi in radian. We typically will, but you don't have to. So in this case, that's going to be 720 divided by pi. So if I do 720 divided by pi, I'm going to get 229.18. So kind of amazing, a small radian measure just like 4 is actually, over 200 degrees, 229.18 degrees. So this measuring angle is very important. Knowing how to go from DMS to regular form, being able to go from radians to degrees is very important, as this is always kind of the first step when you're looking at some of our trigonometric problems we will encounter.